Well, exercise 5C.2, we're going to look again at transformations. We saw last time there are basically three types of transformations. One was a translation. There's actually two types of those. One was a stretch, and again there are two types of those. And one was a reflection, and again there were two types of those. So even though there's three types, in each case there's two types of them we need to know, and the collective name for these is transformations. And you saw this at GCSE. We're going to look at already drawn functions, I call these, and basically the ones where they draw you a graph and say, and it's not a normal graph either, so they draw you a graph and say what happens to this graph, and they might even ask you to draw what happens to this graph. And obviously the picture shows a reflection, so it's quite pretty, so it's a nice way to start. A reminder, there were three types of transformations, as I say, so let's just run through them quickly. When a translation is not in the bracket, and I wrote this as f of x plus a, we describe that as being a translation by the vector 0a. If it is in the bracket, f of x plus a, now I last lesson video talked about this in terms of it being if the x is replaced by, say, x plus a, or x minus 1, I remember seeing in the last example. This is a translation, but it's by the vector now minus a naught. Now, the translation by naught a basically means it's going to move up and down. This one moves left and right. And what we said was that whenever it's in the brackets, this thing that we're replacing comes a bracket, then don't be surprised that it's going to do, first of all, go left and right, but also the opposite to what you'd expect. It says plus a, it actually went left because of minus a here. If it was a minus, then it would go right. So just remember that. And then we had stretches, as I said. Now that basically comes about by timesing, and that's why I've written over here timesing. So it might have been like 3 times the function we already had, or 5 times the function we already had. And this is best described as a stretch parallel to the y-axis by a scale factor of a. So if it said 3f of x there, it'd be a stretch scale factor of 3 parallel to the y-axis. Now this parallel to the y-axis just means it's being stretched up and down, depending, now basically upwards, unless it's a negative number you're timesing by, in which case it will stretch downwards instead. But it basically stretches upwards. As opposed to when it's in the bracket, and notice here again, f of ax. This is a stretch parallel to the x-axis. Now this means it goes left and right, because that's where the x-axis goes. But this time it's by a scale factor of, look at it, 1 over a. It doesn't stretch by a factor of a. Here, a became a as a scale factor. Here, a becomes 1 over a. And because it does the wrong thing. Rather than getting a times bigger, it gets a times smaller, and that the easiest way of describing that is by a scale factor of 1 over a. The last one is what happens if you put a minus in front of it, and we talked about this as a reflection in the x-axis. Now, when you say the x-axis, it looks as if it's different direction because this one says y-axis. But if you think about this, the x-axis is here. So something at the top goes down to the bottom. Something at the bottom goes down to up to the top. And so the x-axis is actually the right line for us to be reflected in if we want it to move up and down. So that's why I've written up and down. The minus is outside, it's a reflection of the x-axis. If the minus is inside the bracket, look at this, it's a reflection in the y-axis. So what we had was something over here, went over there. Something over here, went over there. And so this is a left to right one because it's in the bracket, and then everything in the bracket goes the wrong way round, really. You need to remember that in transformations in the bracket, the opposite thing happens to what you'd expect. Well, certainly for translations and stretches. So here's a first question then. An already drawn function. You'll notice I've drawn you a function, done what it says. It's made up. You can see it's not a proper graph. It's got some straight lines in it. And it just says, what will happen to this if I do y equals f of 2x? And really you can think of this as the x that we started with has been replaced by 2x. So this is in the bracket. The x has been replaced by 2x. And so I think because you can, again, you can also see it's a 2 times. So it's in the bracket, but it's a 2 times. So whenever it's a times, it's a stretch. But because it's in the bracket, it doesn't stretch up and down, it stretches left and right. And because it's in the bracket, it doesn't stretch quite what you'd expect. It's a scale factor not of 2 but of a half. So what that means is every x number is going to get half as big. The y numbers don't change because it doesn't say it's stretch. This is only in the x-axis, or the posh way of describing it is parallel to the x-axis. Some people describe this as a horizontal stretch, but I prefer this phrase parallel to the x-axis, better than even this in the x-axis. So anyway, basically what I have, take a point there, that will be half as far from the y-axis. So you can see it's 2 away, it will go to there. Now this point here is 0 away, so that will stay there. So that one wasn't one. What was this? That was the original point. That's the point I'm making. That 4 will go half as far. The y number won't change, and actually that is what this will look like. Don't know why I've done it in dotted lines. Probably shouldn't have done this. Draw it as a proper line. That is my graph. So when it says copy and copy the sketch and use a new set of axes. So alright, it wants me to draw a new set of axes. So let's do this. I'll do that. And all I want is that was at 2. And that point there was at 1. And how high is it? It's 1 high. That's what I want to see. And this is y equals f of 2x. So let's just rub out what I started with there. Let's get the eraser out. So the great thing about this is I can tidy it up for me. There we go, I've tidied it up. Let's go back to my pen. Now, what does the 2f of x look like? Well, this is also a times, so it's also a stretch. You've got to get your head around which one's which. This is a stretch parallel. And because it's outside the bracket, it goes up and down, so it's parallel to the y-axis. By a scale factor, and because it's outside the bracket, it just does what it says it should, scale factor of 2. It makes it twice as big. So take that point there, it's at 1 high, it will go 2 high. And notice the x value was 0, and it stays at 0, doesn't change. The next interesting coordinate is that point there. Where will that go? Well, it's 2 across, 1 up. Well, it will go 2 across, it's got to go twice as high. The x numbers doesn't change, but the y value is doubled because of this 2 times here. This point here is 4, 0. Well, the 4 doesn't change because that's the x number and it's stretched parallel to the y-axis. But the 0, if I double 0, I still get 0. So what graph does it look like? Well, it looks very much like the other one, but it just goes higher. Now, it doesn't even have to be a good set of scales on this, as long as you show me what they are. That was 2 across, that was 4 across. They went too high. That's y equals 2f of x. That's what I want to see in your work. So if we look at the answers, the first one is, yeah, that's right. So it's y equals f of 2x, and it's a stretch scale factor of a half. I wrote in before. Parallel is definitely better. So you often get away with it, but I have seen times in exams where they were very particular and they wanted to see it. If you didn't write parallel, you lost the mark. So try to write it. Other than that, my graph looks the same. My description is the same. The second one, yep, that looks right as well. We've got starting at the origin, going across. And again, it's a stretch scale factor of 2 this time, parallel to the y-axis. So that's what I want you to be able to do. Now, a couple of exam questions. So this was January 2012, it says, and it draws me this function, and it says it only exists. So this is what this bit means. It only exists between 2 and minus 2. So it's basically saying is y equals f of x exists between there and there. And it only wants me as well to draw my new graphs between those 2 points as well. That's interesting. Okay. So sketch the graph of f of minus x. Well, that's notice that the minus is in the bracket. So you should be thinking to yourself, hang on, that's a reflection. Whenever it's a minus, it's a reflection. And which way? Ah, it's in the bracket, left and right. So it will reflect like that. And so if I was to draw this graph, what would it look like? Well, at the moment it goes across to 2 in both directions. So just make sure yours vaguely does. But you'll notice it's lower on the right hand side. And when I reflect it, I think that will go there. But on this one, it'll go higher on the right hand side. Because it's a reflection. Parallel. or reflection, these should be really in the y-axis. Reflection in the y-axis. The second one says sketch a graph of f of x plus 2. Well, notice the plus 2 isn't in the brackets, it's outside the bracket. This is a translation. And it's by the vector. It doesn't go left and right at all, it goes 2 up. Notice it says plus 2 and I've written plus 2. Because it's outside the bracket, it does what it says it should. So, what will it look like? Well, it was doing at 0, 0, but that's gone up 2. So, at 2 I'm going to do, that's 2, that's minus 2. And that's 3, that's 4. I should have done that on this as well. That's 2, and that's 1. So this is 3, and this is 4, because on this side it goes 1 up to 3, because it did go 1 up before. And on this side it goes 2 up to 4 by the time it gets to there, because it did go 2 up. So that's my graphs. Next one, OCR exam question now, question 2 again, but now it's Jan 2010. But you get the idea, they've drawn me a function. This says it's between minus 2 and 4. Okay, fair enough. And again, they only want me to draw it between minus 2 and 4 on the axes provided. Well, I haven't been provided any, but I shall draw it anyway. Sketch a graph of y equals 2fx. And you think to yourself, oh, I bet the 2 is outside the brackets. Now it's a times, so it's a stretch. And it's a stretch by a scale factor of 2 parallel to the y-axis. Outside the bracket, it goes up and down y-axis. So it doesn't ask me to do that, but I've done it anyway. This is what my sketch would look like. Doesn't have to be too posh. So a vaguely good scale, minus 2. Goes across to 4. I think that stays. There you go. Now, when I stretch it up and down, anything on the y-axis stays on the y-axis. So, and all the x-coordinates won't change. This 2, though, has got to get twice as big. So 2, 4. And you might, just put the marks for the other ones in between. But it was 2 high, it's now 4 high. After 2, it was 1 high. Well, now it's 2 high. And after 4, it was 1 high, but now it's 2 high. So just draw it nice and pretty. Well, wasn't my best, was it? You get the idea. Okay, that's what I'm after. What's the last one? Describe the transformation which transforms the graph y equals f of x, this thing, to this. Notice this. It's been replaced. X has been replaced by the x minus 1. It's in brackets, another way of thinking about it. And it's a minus 1, so therefore it's not a stretch, it's a translation. It's a translation because it's plus or minus something. And it's a, so I'm going to write it's a translation. That's a translation on this, it says that. And then we need a vector. Well, it says minus 1, so it's a translation, but it does the opposite thing to what I'd expect. It says minus, so I know it goes 1 to the right. Notice this is in the bracket, so it's left and right. It does the wrong thing. 1 to the right, none up. Translation by 1, 0. So I think that's it. And in the lesson we're going to start off with exercise 5C again, but we're going to use the worksheet for questions on page question 1 on page 76 because they're a pain in the neck to draw. So I've really printed you off a worksheet to make it a little bit easier for you, and we can talk about that in the lesson. So that's about it. Thank you.